Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we'll learn about the compound interest formula and we'll use it to find an ending balance. The formula for compound interest is given on the screen. It's capital A, capital A, the amount at time t, equals P, the principal, times the quantity 1 plus R over N, where R is the annual interest rate and N is the number of times the interest is compounded per year, raised to the n times t power, where n again is the number of times it's compounded, and t is the time in years. So in the first problem that we're going to do, we're going to find an ending balance using this formula. It says invest $5,000 at 3% interest compounded monthly. What is the balance after 10 years? I want to extract the important information here and label the variables. So let me change colors. Invest $5,000, that's the principal P. That's the amount that's being invested. 3% interest, R equals 0.03, changing 3% to a decimal. Compounded monthly, that means in a year it will be compounded 12 times. Quarterly, you'll have N equals 4. Semi-annually, N will be 2. Annually, N will be 1. We want to find the balance after 10 years. That's our value of t. So we've identified all of the values on the right side of the formula. We just need to work them out on our calculator. So first, I think it's a good idea to always start by writing these new formulas as you learn them before you try to plug in. So A equals P times 1 plus R over N raised to the n times t power. And again, there it is at the top of the screen. Now I want to try to substitute in. I'm putting in 5,000 for P, 1 plus 0.03 for R divided by 12 for N, raised to the 12 times 10 power. N was 12 and N was 10. I'm sorry, N was 12 and T was 10. Now, before we go to the calculator, I think it's a good idea to try to simplify both the number in the parentheses as well as the number in the exponent. And if I look at 0.03 over 12, let me switch to the calculator really quick. 0.03 divided by 12, if that works out evenly like it does here, 0.015, I'm sorry, I divided by 2. I should be wearing my glasses. Divided by 12. If that divides evenly like it does here, 0.0025, then we should make that change. So back here, 0.0025 plus 1 is 1.0025. And the exponent 12 times 10, we know that that is 120. It makes it easier to go to the calculator if you simplified those numbers first. However, sometimes the R divided by N will be a decimal that goes on forever. Then you want to try to do it in the original form. And I'll show you both ways on the calculator. First, the cleaner way. And I've learned my lesson. I will put on my glasses for this one. We've got 5,000 times 1.0025. See that? 25, the exponent key, and then 120. Now this is a financial problem, so we're talking about money in dollars and cents. So we're going to round to 2 decimal places, $6,746, and that rounds to 77 cents. And I'll use the approximately equal because I did round that answer. Now, that was using that formula, but I could also have entered it carefully using the formula that was right above it. I should get the same answer. So let's go back. And we have 5,000. And I'm going to use exactly the way I had it. Parentheses, 1 plus 0.03 divided by 12, tap outside the parentheses, press the exponent key, and while I'm in the exponent, 12 times 10, oops, I need to stay in that exponent, be careful with that, times 10, nope. I think I'm going to have to use parentheses up there too, parentheses, 12 times 10. And notice I get the same exact result eventually. I didn't do this on purpose, but you could see that I did struggle trying to type that incorrectly, and I had to keep an eye to make sure it was putting everything in the right place, especially that 0.10. So that really says that even if you can't simplify the fraction inside the parentheses cleanly, I think that multiplying the numbers in the exponents makes a lot of sense. Anyway, same exact result. So back to the main screen again. After 10 years, you would have approximately $6,746.77.